Hello students, welcome to my video. Back again. So today we are going to discuss about the conic sections of optional math. Okay, so this conic sections. So we are going to discuss about this on this major topic. So I have made some of the assessment, the figures, the definitions, and all those for you you know to make things more convenient to explain. Okay, so let's move on to this. So, so you already know the cone is. You have already known the cone, how it looks, how it is. You have seen that physically and all that stuff. So, and about the conic sections we are talking about. So, what you mean by conic sections? So, this section means the part of cone. Okay, it's just a part of cone. If some cutting plane cut this cone, we call this the right circular cone, cut this cone in different angles, two different angles, two different directions, certain sections are formed, certain figures are formed in those conic area. So, and those figure often are called the conic sections. So in other words, so to make it more clearly, let's see. So this is a cone. You have seen cone there. So if I take this as a cutting plane, if I cut here to in this way, then it forms different conic sections. If I do in this way, if I cut this cone in this way, then it forms another conic sections. If I do it this way, just parallel to the PQ, if I cut this, then another sections will be formed, and those sections we obtained when we cut this cone with this cutting plane through different angles, through different so that's those parts we get from the cone while cutting through this cutting plane, that we call the conic sections. And it might be circle, ellipse, parabola, hyperbola. It might be any, but it depends on the situation how the cutting planes cut this cone. Okay, so we are going to discuss about that furthermore. So if in examinations it asked what is conic sections, then you can use your own language to describe it, to define it, or you can write it like this. Conic sections, the sections on intersecting a right circular cone, which is this, yes, right circular cone, by a cutting plane, by a plane in different positions, through different positions, through different directions, different sections are obtained, and those obtained are called conic sections. Okay, so before I move into the conic sections, those circle part and the ellipse part, let's first dissect this cone parts. Okay, now in this cone there are two cones formed here, and those two cones are formed by this line PQ. We have seen this as, and this PQ is known as the generator. The reason why this PQ is known as the generator is, you see here PQ, when you wind this PQ, yes, whirl this PQ, then from one direction, then this kind of figure is formed, on the upper and on the lower also. So in this way two cones are formed. So while winding this, whirling this PQ line, yes, then two cones are formed. So the reason why PQ is called the generator, as being the generator of the cone, because of this PQ the cone has been generated. That's why PQ is known as the generator of the cone. So here PQ becomes the generator. So nothing more than that, just to let you know. Okay, so now you can see a straight line perpendicular to the base of the cone and passing through the vertex this vertex divides this two cone. Yes, the uh, the tip where two cones get separated, that is called vertex. Okay, so the straight line perpendicular to the base and passing through the vertex, that is called the axis of the cone. Therefore M, and that represents the axis of the cone. Now you know the vertex. Yes. So, and what about this alpha? This is the angle between the generator and the axis of the cone. So alpha denotes the vertical angle. Vertical angle means the angle between the generator and the axis of the cone. So yes, and because of the generator, when it's wandered whirled in one direction, two nappies are formed, the upper cone and the lower cone. The upper cone is known as the upper nappies, and the lower cone is known as the lower nappies. There's nothing more than that. It's very easy to simplify things. So without any further delay, let's move on to the next portions. That is the very first and the easiest one, that is what we call that, the circle. So what, in which situations, if a cutting plane cuts the cone, it forms a circle. So we are going to discuss about that, and furthermore on other coding sections part also. So without any hesitations, without any further delay, let's move on to that. Okay, let's first conic sections we are going to discuss about the circle. So in what case the circle is formed. Okay, so first you see this conic sections, you see this cone here, and this is a cutting plane. So I cut this cone with this cutting plane in such a way that this cutting plane is parallel to the base of the cone, or in other words, this cutting plane makes just an angle 90-degree right angle, cuts the cone, just intersecting this axis of the cone at right angles. Yes, making an right angles with the axis of the cone. So in that case, the circle is formed. So here theta, alpha, you already know, alpha denotes the vertical angle, which is the angle made by axis of the cone with the generator. But here this theta denotes the angle made by the cutting plane with the axis of the cone. Here in this case, the angle made by this cutting plane with this axis of the cone is 90-degree. In that case, the circle is formed. Okay, so if if what is the conic sections, how to define the circles in the conic section, then you has to address this definition here. The section of a right circular cone cut by a cutting plane just parallel to its base, which represent the circle. Either this cutting plane should be parallel to the base of the cone, yes, or in other words also you can say it, when a cutting plane is at right angles to the axis of the cone. When this cutting plane is at the right angles to the axis of the cone, then the section is called circle. So it's easy. Okay, so in this case, when theta means the angle, yes, the angle between the cutting plane and the axis of the cone, if that theta is equals to 90-degree, then the circle is formed. Or the cutting plane must cut the this what we call that, this cone, in such a way that this cutting plane is parallel to the base of the cone. In that case, the circle is formed. So for the circle part is easy. Okay, let's move on to the another part. Another part will be, I think, ellipse. Okay. Okay, let's move on to the next point, parabola. So when the parabola is formed, how the cutting plane should cut the cone so that it can form the conic section so formed, that will be parabola. So let's move on to this. So this is a cone. So right now I have cut this cone in such a way that this cone is just parallel to the generator. You see this generator here? So let's this mark as MN. So this MN is just parallel to the cutting plane. So in that case, there forms this kind of figure. So if I zoom it here, it forms this kind of figure, which is known as the parabola. So in this case, this generator is parallel to the cutting plane. So this vertical angle will be equals to the theta. So in this case, theta will be equals to vertical angle. In such case, parabola is formed. So how to define this? The section of a right circular cone by a plane parallel to the generator of the cone represents the parabola. The section of the right circular cone which when cut by a plane, the section of the right circular cone which when cut by a plane parallel to the generator, so that conic sections represent the parabola. So in that case, so you can make it with your own language. Yes, you can make it with the sentence with your own language. Parabola is formed when the cutting plane cuts the right circular cone in such a way that the cutting plane is parallel to the generator of the cone. Then parabola, so formed conic section is called parabola. So in that case, the alpha will be equals to theta. Alpha vertical angle will be equals to theta, being corresponding angle. So let's dive into the another part of conic sections without any further delay. Okay. Okay, now let's move on to the another conic sections part, that is ellipse. Okay, so you already got the figure of ellipse in the board also. So in what case ellipse is formed? So in this case, for the part of ellipse part, so you have seen this cone. Now this cone is cutted by the this cutting plane in such a way that neither this cutting plane is parallel to the generator, nor this cutting plane is perpendicular to the axis of the cone. In such case, ellipse is formed. If this plane becomes perpendicular to the axis, then it will form a circle. If this cutting plane is parallel to the generator, it will form the parabola. Yes. So it should be, the cutting plane should cut the cone in such a way that it should be neither be parallel to the generator, nor it should be perpendicular to the axis of the cone. So in that case, ellipse is formed. So if you have to define ellipse, then you can just make it with your own language. So ellipse, section of a right circular cone when cutted by the cutting plane in such a way that the cutting plane is neither parallel to the generator nor perpendicular to the axis of the cone, then the conic section so formed is called ellipse. Now in this case, the value of this theta is lies between the angle of vertical angle and between right angle 90 degree. So the value of this theta must be greater than vertical angle and below than right angle, that is 90 degree. In that case, ellipse is formed. Now the final most, we're going to the final most point, that is the final most conic sections, that is hyperbola. Okay, so without further delay, let's move on to that. Okay. Now finally, last but not the least, we come to the final, the sections hyperbola. Okay, so for the hyperbola to make, the cutting plane should cut the right circular cone in such a way that it should cut both the nap, upper nap also, lower nap also. So it could be the situation here is either this cutting plane should be parallel to the axis of the cone, so it can cut both the naps, okay, of the right circular cone, or it should inclined to the it should inclined while cutting while cutting the cone in such a way that it cuts both the upper nap and the lower nap. Doesn't necessarily that the cutting plane should be parallel to the axis of the cone. It cannot be also parallel, but it should just cut the upper nap and lower nap, both the nap of the cone, right circular cone. So in that case, we get this type of figure. Only one type of this, that will be parabola. Now this type of figure, two opposite parabola, two parabola which opposing each other. So this is called the hyperbola. So for this, for this reason, for this hyperbola, you can state it like this, when the double cone is cut by the cutting plane parallel to the axis, is the first situation that mentioned in the figure here, then we get the hyperbola. It is must that the cutting plane should cut both the naps at the same time, and only hyperbola is formed. As here becomes two parabola, just opposite with each other at the same time, two parabolas formed, and this combined together we got this hyperbola. So when the double cone is cut by the cutting plane parallel to the axis, then we get the hyperbola. Or you can also state it like this: when the cutting plane is inclined to the axis, such that it cuts other part of the double cone. Yes, both the double cones should be cut by the same cutting plane, so in such a way that this cutting plane should be inclined into that cone. Yes, so the axis of the cone, it also cuts the other parts of the double cone. The section is called hyperbola. The section so formed is called hyperbola. In this case, this theta will always be smaller than the vertical angle. Yes, I might be wrong with, it must be greater than vertical angle. Yes, it's smaller than vertical angle. In this case, theta should always be smaller than the vertical angle. I got it here on one. Okay, so this much for today. I think this conic section part, you are much more clear about this. Okay, so people, students find this part a little more tedious. Okay, they don't enjoy this part. That's why I try to make you understand this part as much as I can, so it will be convenient for you in the examination. Not much question will be asked from this portion, but it will help you from this. It will help you a lot, I guess. Okay, so for today's video, this much for. I would like to end this video here. So if you like my video, don't forget to like, subscribe, and share it to your friends circles. Okay, so until then, next time, take care, stay blessed. Okay.